Custom cables. In this case, it's when you take two different kinds of cables, such as connectors for meters, and splice them together, as if they were one cable originally. I've done a video about this before, but this is a better, nicer method. Now, why do you want custom cables? Because the cables you might want don't exist. Because obviously you should buy purpose-built cables if they exist, because they'll be manufactured as one piece. It'll be even better than this, but this is the next best thing. For me, I do a lot of stuff with breadboards. That's the main thing I do. But multimeter cables, oscilloscope probes, coax cables, all these cables, even the cables from my power supply, were not designed with breadboards in mind. They have clips, they have probes, they even have needle probes, but they're still not small enough for a breadboard. And I did look. They don't make breadboard cables for all of these things. I guess the idea is that the cables they provide are made for real work, and breadboarding is just hobbyist stuff. I guess I can't disagree, but why am I going to let that stop me? So I just take my wires, the jumper wires used in a breadboard, cut them off and use the connectors because these are super cheap, and make custom cables out of them. Last time I used crimp tubes, which I'm sure people like. They're quite common, but I have found that they don't allow you to solder the wire to itself, which would provide a better connection. And they're also less secure. Maybe if I had a super expensive crimp tool or something, it would be a little better. But what I'm using is heat shrink tubing. It's basically just the rubber insulation that you'd have, rubber or whatever, plastic, that you'd have on a wire, except it's not on the wire yet. And you use a little heat gun I got off of Amazon. I got a real nice one that's got adjustable everything, and it wasn't even 50 bucks, it was like 35 something. You can get cheaper ones if you don't mind it being not quite as featureful. But it's just a little heat gun, and I got a little assortment pack of tubes. If you know what size you need, then just get those. But this will be nice for different purposes. So the idea is I'm going to solder the wire to itself, or rather the two together to a point, and that's going to give you the best connection. The flux in the solder is going to clean away oxidation, they're going to be physically connected and the solder will lend some strength without sacrificing too much flexibility, and then I'll use the heat shrink wrap to insulate it as if it was originally a wire. Now that I've spoiled the ending, if you don't actually care to watch me do it, I guess you're done. But for anybody sticking around, here's a demonstration. So let me prepare my soldering iron, and here's my heat gun. Just looks like a hairdryer. It basically is a hairdryer. My little clamps to make things easier, 2 standard multimeter probes, just the ones that came with it. You can buy an extra set if you want to mess with something else and keep the originals. Also, something to keep in mind, if you see that they're just these tiny little tips, there's actually a little part on the front that comes off. You can just pull these little things right off, and this is meant for you getting in there to longer things. If you put these on, that's just designed for dangerous situations where you want to make sure to not touch more than you absolutely have to and not short anything out. But we're not going to be using this anyway. This part's going because this is the probe that does not fit in the breadboard. I'll take a red wire and a black wire. These will be the sacrificials. Some solder, my tubing, some scissors, because the tubing is pretty long and I can get 2 uses out of one, and some wire strippers. Now, if you're on a super budget, you obviously don't need all of this. Instead of having a fancy third hand kind of device, you can just use whatever handy surface there is and some clothespins, that sort of thing. So let me get some of this out of my way. So the first thing to do is to actually connect the wires. Nothing fancy here, you basically just cut them and then strip them. So in the worst case, I can always cut some off later. So I'll leave myself the maximum slack now, and I'll cut as close to the useless part as possible. This is soft wire. You can just use scissors instead of wire cutters. No big deal. Now, if you were thinking of reusing these instead of pitching them, then you would want to actually leave a lot more cable on because then you could connect them to something else. But I'm going to pitch them because I have like 6 or 7 of these now. They're cheap. So into the bin they go. And now, since I have no idea what wire gauge this is, you start big and work your way down. So that's really loose. So let's try this one. There we are. Just basically start big and go smaller. So I'll strip the other one. There we are. So that's the 2 multimeter probes stripped. And of course they're using stranded wire because it's more flexible or whatever. So just basically twist it, spiral it a little bit just so it doesn't get out of hand. It doesn't need much, just a tiny bit, so it doesn't fray. So just twist this one as well, nice and easy. And then I will take the breadboard wires. I'll cut them in about half so I can use the other ends as well, because these are male to male, so I can make a second set of wires with them. And once again, I don't remember what gauge these are, so we start big and work our way down. That worked fine. Let me go ahead and Get the red one. There. And these being stranded as well, I'll give them a bit of a twist. Do the chubby checker. Nice and easy. Now I'll put my strippers out of my way. And the 2 unused portions I'll set to the side and use those later. So now we have the multimeter probes stripped, the breadboard wires stripped, and I'm going to clean off my soldering iron. If you've left it for a while, just put some nice solder with flux on there. It'll clean it right off. That's what the flux is for, removing oxidation. There we are, good as new. So I'll just put the red breadboard wire in a clamp, and now I'm going to just tin it a little bit. Just apply solder onto the wire. That will secure it from fraying because it is stranded. Basically, I'm just tying the strands together, gluing them together, trying to hopefully get some solder in the little frays, but that's not going to matter much. That's one side. Do a little bit over here. I've really got to get a better workstation set up. Problem is, without workstation furniture, I'm just improvising with office furniture. But there we go. And now, since there's insulation on there, I'd like to let it cool a little bit, so I'll just use another clamp. Pick up my wire from the floor. Now let's do the black multimeter probe just the same. I'm just tinning it a tiny bit to make sure the strands behave themselves. Anything we can do to make our lives easier. All right, we'll let that cool. So now I'll do the same thing with the breadboard wires. Just clamp it in. Try and straighten the wire a little bit and tin it up. These are much thinner than the multimeter wires, but the multimeter wires are also made for working with wall power. They can take 600 volts and up to 10 amps. All right, so that's part of it. Ow, careful where your hand goes. So those will definitely be cool now, so I can bring my clamp back over, do the black wire, just get a little solder on this wire and make it behave itself. That should do well enough. So now I have my 2 wires, my red multimeter probe and my red breadboard wire. And you could put the heat shrink tubing on first and just let it sit somewhere on the wire while you finish soldering the wires together. That's important if you're using tubing that's thin and you have a connector it can't get past. Like if you have a big bulbous connector. This, for example, this is much larger than the shrink tubing we'll be using. So you might want to put it on before you connect the 2 wires in case both ends are big like this. Because you could make custom cables for more things than just breadboards. But I'll go ahead and connect them and put the heat shrink on later. So basically I just got these both in my clamps and I have to wiggle and finagle until they actually sit properly next to each other so that I can solder them. Try and bend it a little bit. That's probably the best I'm going to do. So now I will very gently solder them together. I'm not gentle because I'm worried about harming them. It's just that this is a little picky. If you can get them connected at all. So there's a little solder on there. So if I warm it and push them together, there we go. Now that'll hold. So all I did was basically solder them together at one spot. I'll use my scissors to crush it down a bit, or just my finger because it already cooled. So now solder somewhere that's not that spot so you don't remelt it. Try not to apply the heat for long. Just solder and get out, just like making a solder bridge. Solder back and forth at different spots. Don't let it get too hot. This is essentially just solder bridging. And also don't worry about making it pretty because you're not going to see it. So there we go. Let it cool for a moment. Take a look. Like I said, it's not particularly pretty, but it is definitely functional. Don't rip it apart. Take a look. It'll get the job done. So now let me leave that to cool. So I only turned my heat gun on once, and we'll do the black one. So clamp the black, multimeter probe, find the black breadboard wire. Has it gone on the floor? Is it under my third hand? Oh, it's still clamped over here. Oh my goodness. There we are. It blended in with the shadow, see? So I think that's probably an easier technique. Let me just put a gob of solder on this iron on my tip. Hold them together and just touch it. There we go. A great technique. So just hold them in one spot so you can solder the rest of it. That's easier. See, discovering techniques live. This is why you keep doing things. You get better and better and better. So now I will just apply a bunch of solder, try to get them to stay together, and that looks good. Remember to use a fume extractor or don't breathe in the fumes. So we take a look. That'll do fine. So now while that cools, I'll take my first one, the red one, put it back in the clamp for a second so I can see what I'm doing. And now we get out some heat shrink tubing. You want to use the smallest tubing you can because it's not magic. It shrinks only so much. In this case, it says 2-to-1 shrink ratio, so it'll get about half as narrow. So we try to find the smallest thing that will go on this wire, which is probably this one. Let's put it on and see. This was why I got an assortment pack, so I can just experiment. So there we go. That fits on. Actually, that fit on easily, so let me try one size smaller, just in case. It does fit. Ooh, it's got a lot of friction in there. It might not, but if it will, if I can just get it on there, aha. Yes, that's nice and tight. So we'll get a nice tight seal if I do that, because it'll just barely fit, so that's great. So now I'll just cut it in, actually I'll cut it in thirds. This is a really big piece. Of course, that went right in the water, so I'll set that aside to dry. Because see, the solder connection is here, so this goes on the insulation of both. So it's definitely a long enough piece. So I'll go ahead and slide that on there, ready to go. There we go. And now my other cable will have cooled down. So I will similarly clamp it. Let me put the sleeve on and then clamp it. So we just slide that right on carefully. Otherwise you'll have to redo the soldering. There we go. Nice and tight. So I'll just push that down and clamp it there. And then I'll reclamp this so that the middle part I'm working on is actually between two clamps, because I'm going to be blowing some hot air. So now we're basically done. All I have to do is shrink this tubing. Let's make it straight. That's probably another good point. So it'll shrink straight. There we go. That should do. So it just barely fits on the big one. It doesn't even have to shrink but less than a millimeter, 1/10 of a millimeter. So hopefully it'll shrink enough over here. We should be all right. We have some extra room. So I'll take my heat gun, set it to an appropriate temperature, and turn it on. Hopefully this won't be too incredibly loud, but it should be all right. So just wait for it to warm up, and then from a distance, go at a distance first and then bring it in. So bring it in gently, watch it shrink, let it shrink nice and slowly. No reason to overdo it. I just realized it's on backwards. There we go. Now we got some heat. The adjustable temperature is a little weird, so now we get there. Now it's going to shrink. There we go. Now it's shrinking. You're not in a hurry. Not in a hurry at all. It'll be perfectly fine. You don't want to melt your insulation, so give it a second. It shrinks quickly. You don't have to sustain the heat. So I'll lean in, and yeah, it's shrinking a lot. That really feels like it's more than 2 times. So I'll get some heat on there, look at it. That's probably about all it's going to give, but there we go. Now I'll shrink the other one down here. Just apply the heat gently, not in a hurry. You know, once is enough, you do it right, you don't have to worry about it again. And there we go. Take a look. Doing nice. Let's shrink that a little more if we can. Yep. Oh, it's working perfect. Just give it one more quick little pass over right on the end there. But I think we have hit our shrink limit. And we turn the heat gun off. Now, it says to hold the heat gun like this. There's a little thing on the handle here, if I can show you. So basically rest it on the table so that the heat is up, because the heat is going to rise basically by convection. If you have it on its side, or even just down like this, the heat will go into the gun and it'll warm up the circuits in there and everything and wear it out. So you want to have the heat on the top to dissipate it, because when it's on, there's a fan blowing the heat out. But when it's off, it's only convection. So just have it nice like that. Also, I forgot to turn off my soldering iron, so let's turn that off. So there's the soldering iron and the heat gun cooling down nicely. And we have our wires. Now this end, the end with the breadboard wire, is not completely shrunken on because, again, this is only 2x shrink. But here it's nice and tight. So if I take this off and we can get a better look, it's rigid. It's not inflexible. It will bend, but it bends rigidly. So it's a nice strong connection. So you've got the solder giving an excellent electrical connection. The only thing better than soldering the wires would be as if it was one wire. So do buy a pre-built wire if you can, but solder is the next best thing. So the wires are soldered for a great connection, and the heat shrink tubing with the solder is giving it physical stability. So it doesn't really matter much that this is loose a little bit in this end. It was the disparity in wire size here versus wire size here. I had to use a bigger tube to get on this, so it didn't shrink all the way here. But it's fine because the solder plus the stickiness is nice and rigid. And the black wire, which you can't see because the background is also dark, the black wire is just the same. It's a tiny bit wiggly over here, but the actual connection is soldered here. The solder is thicker and it's shrunk around the solder and the bigger insulation, and it's nice and stiff. Perfect. So this, I have concluded, is the #1 best way to make custom wires at home without spending a whole lot of money. The heat gun was something like $25, $35, I forget what, but you could certainly get a cheaper one. Don't buy the one in the hardware store. That's just a ripoff. I got a horrible one. I just don't trust stores anymore. Just order online where you can see the reviews, and it's not just a little Bic lighter inside a plastic case. But grab you a little heat gun, grab you some heat shrink tubing. The heat gun will last you forever. The tubing, just get a case of it, it'll last you forever. It's not like you're going to make that many custom cables. And then as you get further into electronics, the heat shrink tubing will also work there, because if you're building components, you can use them to seal off wires. You have screw terminals, whatever terminals. You know, you make a custom mod for your little RC quadcopter, drone, whatever you buy. You can use heat shrink tubing there to make it waterproof, because, you know, cover up any metal, cover it with insulation, and it's waterproof. So it's cheap, it's easy, it's quick, and it's good. So while I do the rest of my wires, I'll be seeing you.